All right. We're 1 minute over our start time, so I think we'll get started, and I'm sure there'll be still be a few folks joining in kind of as we go. Thank you very much for taking the time to join this webinar on building agentic systems on AWS using serverless. My name's Adam Wagner. I'm a principal serverless solutions architect at AWS. I've been at AWS a little over 10 years. So I'm one of those people who still remembers when kind of serverless was born with Lambda, and have followed it since then. Really excited to chat with you today about building agentic systems. As I'm going through this presentation, feel free to ask any questions you want in the chat. I'm joined by a number of my colleagues who can help answer those questions asynchronously in the chat. We'll kind of talk through building agentic systems for probably about an hour, after which we'll switch over to getting our hands dirty and getting hands-on with a couple different labs building agentic solutions. So without further ado, I will jump into the presentation. All right, so we're at a really interesting point where AI is going from kind of being an interesting toy and a cool thing to play with to something that can now start to really make a difference in enterprise processes, especially when you bring in agentic AI. And so we'll go through, spend a few minutes just kind of talking about what an AI agent is, talk about kind of how they're different from some other ways to use AI, in particular AI workflows. Then we'll get into the specifics of building AI agents on AWS, and some things to consider and kind of action items, things for next steps. This I hope is a very accessible way of looking at agents. Myself, I kind of come from a development and a infrastructure architecture background. I don't have a deep machine learning background, and I think that's one of the things about agentic AI that is so exciting. If you know how to build an application, if you've designed microservices, you can build an agentic AI application. And we're going to talk about how to do that today. So to start it off, a little bit kind of backwards from how some talks go, like three kind of main takeaways that we'd like you to take away from the talk. And the first is that context is everything. And when we talk about context, context is all the information that you're providing to a large language model when you make a request in an agentic system. And if that doesn't fully make sense yet, don't worry. We're gonna dive into it and we'll figure it out. The second is AI before agents. Keep it simple. Agentic AI is definitely, there's a lot of buzz around it. It is really fun to build an agentic system and see it work. But sometimes you don't actually need a full agentic system. You might just be able to make a single Gen AI call to accomplish something, or a couple Gen AI calls that are orchestrated in a specific deterministic way. And so just make sure that you're making the system as complex as it needs to be, but no more complex. And then the last one is leverage a microservices architecture, start small, build small and scalable. At the end of the day, agentic applications are just software applications. And so, the lessons learned from building microservices apply here as well. And so we don't want to lose track of that. So what are AI agents? So we have a definition here: software applications that can independently accomplish a goal that requires thoughtful and adaptable use of reasoning, judgment, tools, and resources. So again, they're software applications. It's not magic. It can kind of look like magic at times, but really they are software that can use their reasoning ability to act in an iterative manner, evaluate results, and continue to work towards some end goal. They don't just kind of answer a single question, they can solve problems through a process of basically like exploring their environment and then, refining their answer. So why should you care about agents? I think agents have the potential to make all of our jobs more interesting. If you just think about your job and what are some of your least favorite parts of your job, there's probably a potential to have agentic systems in the future take over some of those things so that you can focus on the more valuable things that you do throughout your work. And we see that enterprises are really doubling down on agents. So, a couple statistics here from Gartner. Gartner thinks that by 2028, a third of all enterprise software apps will include agentic AI, up from 1% in today, basically. And that 15% of day-to-day work decisions will be made by autonomous systems. So pretty cool. It paints a really interesting picture. And so what are we seeing customers build today? What agents are we seeing? We're seeing a lot in the workplace productivity space. We're seeing some of this with coding. So seeing multiple customers that are building agentic systems to handle various parts of the software development lifecycle, code reviews, code assistance, that sort of thing. We see a lot of business process automation. So basically, you think about everything from kind of demand forecasting to incident management to customer service. A lot of those workflows we see starting to be handled by Gen AI agents. And then innovation and research. So if you think about, data analysis in the financial services space, where you're taking in all the available information about a public company to do some research around their stock price or something else, a lot of that initial data analysis can be done by an AI agent. We're seeing a lot of things done in that space. Similarly, in the healthcare and life sciences space, if you're researching a new disease space to go into for a new drug or a new therapeutic, it's another type of research where you gather that data and use Gen AI to create a first pass summary for what you're looking for. All right, so now that we've kind of talked a bit about like what we think agents will do, I want to kind of take a step back to kind of where a lot of us probably use Gen AI for the first time and build from there into what an agentic system looks like. So I don't know about you, but the first time I used Gen AI, it was in an interface that was similar to this one. So yeah, this is the Claude interface from Anthropic, but this could also be ChatGPT or any of the other chat-based experiences. And you have this prompt here, and you send a question into this AI assistant. That AI assistant is sending that prompt to a large language model, an LLM. Those LLMs are trained on a huge amount of data. You ask questions, and based on all of that data that it's been trained on, it's going to give you a response. I played with this. It was super fun, really interesting. There's all sorts of stuff that you can do with it. So we could have it write a poem about serverless. I think it does a pretty good job. That's a pretty decent poem, probably better than I could do. Um, and so you can do these kind of fun things. But there are like limitations. The first one is that LLMs are trained in the past, right? There's always a cutoff window in terms of the training data that is used to train uh, these models. The other thing is that LLMs by themselves are stateless. They don't retain memory between interactions. And so, yeah, that's something that kind of needs to be overcome to accomplish a lot of things. And then LLMs, they can generate content, but they can't actually take actions, right? If you think about that model that I was showing there, um, like Claude Sonnet, it responds in text. Everything that it returns back is text. It can't actually perform interactions on any other system by itself. And so, how do we solve these problems? Well, this comes back to one of the key points that I talked about, which is that the context is everything. And when we talk about context, we're talking about everything that is sent to the LLM model. And so let's break that down and show you what that looks like. You'll also often hear the term context window referred to for a given LLM. That context window is the maximum size of context measured in tokens that you can send into a given model, and it changes depending on the model. So let's go back to the AI assistant type of scenario. So, this is just like that, web chat interface that I talked about. You have an AI assistant. The user asks a question. The AI assistant sends that user prompt, that question, to the LLM. The LLM sends a response back. Well, maybe you want to give your AI assistant a little bit of a personality so that when you interact with it, it's just a little more fun. So now we're going to use something called a system prompt. So this is another prompt that we're going to add to the user prompt every time we call the LLM. And in this case, the system prompt is that the LLM is the world's best French chef. And so now we have this composite prompt that is the combination of the system prompt and the user prompt. And now when we say, how can you help me, to our AI assistant, it responds as if it is a world-renowned French chef. So, we were able to really change the behavior of our AI assistant by tweaking that system prompt. So let's use like a similar technique to give our AI assistant memory. And if you've used an AI assistant like ChatGPT or Claude, you'll know they do this, right? They understand what you asked previously. The way they do that is they maintain a history of the messages that you've sent in, and those are sent in as part of the context, as part of that composite prompt. And so now when we ask a question of our assistant, we're sending in the user prompt, the question that the user asked, the system prompt, and the history of all the previous messages. So we have lots of context that we're providing to our assistant. But what if we wanted to know about, we wanted to ask a question about data that LLM wasn't trained on? So maybe something specific to our company. That's where a technique called RAG, or retrieval augmented generation, comes in. So if I want to be able to ask a question like this, show me the final sales data for my department last week, I need some way to get that underlying sales data into that large language model because it wasn't trained on that. That's private data just for my company. How am I going to get that in there? So with retrieval augmented generation, we use an enterprise knowledge base, which could be any number of different data stores. It's usually a vector data store because we want to be able to you search for that data in a useful semantic way. And what we're going to do is when the user prompt comes in, we're going to take that user prompt and search the enterprise knowledge base to get relevant data. And then we're going to take that and add it to the context. So you see now in our composite prompt, we've got the user prompt, the system prompt, the history, and that retrieved data that we got from the enterprise knowledge base. We send it to the LLM, and the LLM gives us a response. And so this is a very powerful technique. And now we get some nice made up sales data. And so, just to reiterate, right, like context, super, super important. The context is the only memory the LLM has. It's where you're going to give it data that is specific to the use case that you're asking about, data that it wouldn't otherwise know about, past conversations that you've had, the results of calling other external tools, all of those things are going to go into that context. And so it's important to know what's in there, understand how it's working. And so now we've shown kind of how we can give it a personality with a system prompt. We've shown how we can get enterprise data using retrieval augmented generation, but we're still not quite at the agentic level. One of the things that often brings us into the agentic is the need for kind of real-time context to be asked dynamically. So if we want to ask for the weather forecast tomorrow in my city, we know LLMs were trained on data in the past. And so without some sort of external data source, it's not going to be able to answer this question. So how can we make it so that it can answer that question? Well, when we send in our query, we can send in the user prompt and we can add in there a description of tools that are available that the LLM could ask the assistant to use in order to get more data. This tool could be a weather API that gets us that data. And so what you end up having is you have the user prompt that goes in. We're adding in those tool descriptions. The LLM decides what to do. It says, oh, you know what? I'm going to call a tool. And when it says call a tool, the LLM doesn't call the tool directly. It tells the agentic assistant what tool it wants to call. The agentic assistant calls that tool, gets the result, and returns it to the LLM. And the key here is that this doesn't have to be just a single tool. This could be multiple tools. And we're allowing the LLM to decide what tool it wants to call, right? We might give it a description of 20 different tools, and the LLM is going to decide which ones it wants to call and when. And it can choose to call tools, the same tool or different tool multiple times. So it might call that first tool, get one piece of data back, decide it still doesn't have enough data to return the final response, and it can call another tool and another. So it can call a large number of tools. And then eventually, when it has all the data it thinks it needs, it's going to return that final response. And so this is an example of a simple agentic workflow. And so this is transforming from this intelligent system to something that can really take action and do things, update its own context. And this ultimately is an agentic AI system in a nutshell. We have an input that comes in along with whatever additional context we send in with it. That's almost always going to be a system prompt and a description of tools at the minimum. There might be other things too. And then the LLM is going to do some reasoning. It's going to say, what do I need to do to accomplish this task that I've been asked to do? It's going to pick a tool. It's going to have the assistant execute that tool. It's then going to get an updated context that has the results of those tools, and then it's going to do the same thing again. It's going to say, hey, do I know what I need in order to produce the output I need? And so that's the agentic loop in a nutshell. Hopefully that makes sense. I know I'm going a little bit quick, but again, feel free to ask questions, in the chat. It looks like yeah, it looks like there are a number of questions in the chat and people are answering them, so that's great. Glad to see that. So that's the agentic loop in a nutshell. I now want to switch gears a little bit and talk about kind of AI workflows. And AI workflows sometimes look like they're agentic and sometimes a little less agentic. And so you could imagine creating a workflow where you want to potentially call some tools and you want some of the features of an agentic workflow, but you might want it to be a more defined step-by-step process. And that's where we see things like AI workflows really playing kind of a key role here. And so, these are a couple different examples of, what that could look like. So, you get an initial problem that comes in, you break down that problem, you decide kind of what actions you want to take, you observe those results, and then you move along. There's the one on the left, you're kind of having the LLM decide what policies it needs to look at to answer a question, but it's just like a single tool call as opposed to on the right where you kind of have, multiple tool calls. And so you basically like have agentic systems, and agentic systems in general are highly autonomous and they're not deterministic. In general, there's kind of low determinism. So even with the same input, you might give a workflow, you might give an agentic system the same input, and one time it might make two tool calls to answer that question. Another time it might make four. There is a degree of non-deterministic ness with LLMs, and so with agentic systems where it's making the decision of what to do next, that kind of non-deterministic nature gets amplified. Whereas with an AI workflow, you're kind of constraining that non-determinism, but the trade-off is it's not as highly autonomous, right? So a workflow is going to accomplish kind of a more set number of tasks. And so as we think about both of these, both like AI workflows and agentic AI, it's important that we be careful not to build a Rube Goldberg machine. So Rube Goldberg machines are named after a person named Rube Goldberg who used to draw these pictures of these very complex machines that, would accomplish a simple task like pouring tea by doing multiple steps, which is all just to say, like, you want to keep things as simple as you can. So, sometimes you need an agentic system. Other times you might just be able to call an LLM and do single LLM calls to accomplish what you want to accomplish. Okay, so with the ground set, let's now dive into what it looks like to put this into practice and build an agent on AWS. So we're going to build an agent that can be basically like a corporate travel agent. So book me a business trip to New York City. So we want to be able to build a travel agent that will enforce corporate policies and help my employees book business travel. And so we're going to kind of talk through how we could build this. And so if we just kind of break this down into what you might need, right? If you're going to book a flight, you need to be able to search for flights. You need to be able to reserve a flight. We need to be able to get a booking, like look at an existing booking, and we probably need to be able to cancel it too. And so we kind of need all of these as tools. So we'd need to build these as tools. And so, we're back here. Instead of calling it a generic AI assistant, we have our travel agent. And when we query our travel agent, we're going to send in the prompt. We're also going to send in a description of tools. And so depending on what the user asks for, we're going to invoke a given tool. And so that's a high level of kind of what we want to build. So now let's talk about the AWS services that we could use for all of these different boxes. So first up, we'll talk about the LLM. So to call the LLM, we'll use Amazon Bedrock. Amazon Bedrock is really powerful because it has the broadest selection of fully managed models from all sorts of leading AI companies. So this is great because it allows you to use the same simple API to call multiple models. If there's one thing I've seen working with customers building these systems, it's that over time, the model you're going to want to use for a given system is going to change. These things are moving and maturing at very quick levels. And so, the model that you used for a travel agent use case a year ago is probably not the model you would choose to use it for it this year. And so this allows you to really iterate quickly, really easily try out different models using the same APIs. And so it really just kind of cuts down that time of experimentation and finding the right models. So then we need to build the agent part of it. And from an AWS perspective, we provide both pre-built kind of agent products as well as multiple ways to build your own agents as well. And in this example that we're going to walk through, we'll look more at strands and how to do that. But we also look at how you could build. In this case, we're going to get to building this as an agent, but we'll also talk about how you could do this with. We're going to do it with strands, but we'll talk about how you could do it with AWS step functions as well. So AWS Step Functions is a visual workflow builder that allows you to create workflows, orchestrate calls to various AWS systems in a variety of ways. So you can drag and drop in calls to AWS services, like this call to Bedrock, and it makes it very easy to do things like human in the loop, integrate with third-party services by calling APIs. As I mentioned, call AWS APIs. And so you can use step functions to build agentic type systems. So this is an example of a simple agentic system built on step functions. So you can see at the top that it invokes an LLM, and when it invokes that LLM, it gives it a description of the tools and the prompt. And then the LLM responds with an output. Depending on that output, the choice state either chooses, hey, I need to make some tool calls, or I'm ready to generate the final response. So if it needs to make a tool call, it decides which tool to use, and that's in the output. And then it runs the tool that is asked for, returns the response back to the LLM, and then the same decision is made again. And so this is really useful if you want this visual type of building. And it's also very useful if there's a bunch of deterministic steps that you want to put before or after the agentic part of your application. Step Functions really excels at those type of deterministic steps. And it's really nice from an operations perspective as well. You can visually watch a workflow execute, see if there's problems, restart a workflow kind of from a failed step if something goes wrong. So there's a lot of different pieces that you can do there. So I also mentioned Strands. So Strands is an SDK, an open source SDK for building agentic applications. And it's very easy to use. Generally, you can get started and write like a very simple um, workflow in the matter of very simple agent in the matter of minutes. It supports both. I saw a question about MCP go by in the chat. It supports both kind of local tools as well as remote tools via MCP servers, and we can get into kind of what that is. Supports very easily interacting with those models on Bedrock, but it also supports third-party models as well. So you could write an application in Strands, you could have it call, maybe you have a custom model that you've taken one of the open source models and customized it, and you're serving that model yourself. You call that from a Strands agent. So you can really call any model. And so let's take a look at creating an agent using Strands. So here's getting started with Strands. So this is Python, and we're going to import the Strands SDK, and then we're going to choose our model. We actually don't have to even configure the model. There is, like, by default, it will use Claude Sonnet, but we'll explicitly configure the model, and then we'll create an agent. And so we say, please create this agent and use this model. And then we can send the agent a prompt. And that's what it looks like to send an agent a prompt. We just say agent and we send it the string we want to send it. And when we do this, we get back a pretty generic response, right? Because there's nothing else to tell that agent what it can do. So it's just kind of telling us, here's what an LLM can do. We can then add a system prompt, right? We talked about this earlier. We showed like a system prompt that told it was a chef. But here we're going to tell it you're an enterprise travel agent for Acme Corp and you help book business travel. And so now when we ask the agent, how can you help me? We get back a very different response. We talked earlier about how the history of what you've sent to an agent before is very important. And one of the things that Strands is doing for you is it is going to create the session persistence so that when you're talking to an agent, it knows the previous things the previous questions that you've asked the agent and its previous responses. And so let's prove that out. So now we're going to send in two different prompts, and these are separate prompts, right? Each one of those agent calls is a separate prompt going into the LLM. And so the first one says, I've always dreamt of visiting Tokyo. And then the second one says, what language do they speak there, right? Where there is clearly related to the previous prompt. So if it had no memory whatsoever, what language do they speak there wouldn't make any sense. But because Strands is taking care of this for you, we get an answer that makes sense. So in Tokyo and throughout Japan, the primary language spoken is Japanese, right? So it's taking care of handling that session state for us. And so that's good, right? We like that. But there is a problem with state, right? And the problem with state is if we're going to take this Strands app and we're going to deploy it into production, you're not going to have just a single instance of that agent, right? We're going to scale it out. We're going to have a number of them running. And if we have a number of them running, how do we make sure that each request goes to the right instance of the agent so that it has the right history? You could try to do fancy routing magic, but really what you want to do is you want to externalize that state. So let's go back to Strands and see how we could uh, externalize that state. So so first off, we can kind of inspect the state. We can see it by looking at this agent.messages property. And so if we print that, we see it's basically just a list of JSON objects representing the previous conversation. So, the user said, book me a trip to Tokyo, and the assistant came back with an answer. It's got both of those. And so how do we externalize this state? So we can externalize this state in a number of different session stores. In our case, we're going to be using S3. It's fast, cheap, scalable, and supported by Strands out of the box. And so, prior to an agentic interaction, I actually want my agent to go and get that session state. And then when we have an interaction, I want it to update that session state and write it back in. Strands really takes care of all of that for you. I just need to tell Strands what I want to use for that session manager. And so we can use the built-in S3 session manager. We give it a session ID, we give it the bucket and the prefix, and then it takes care of storing and retrieving that for us. The tool support question. So, folks, someone in the chat earlier asked about, like, when you say tools, do you mean MCP servers? MCP stands for Model Context Protocol. And Model Context Protocol doesn't need to be this magical, complicated thing, but I think it often confuses people. The way I think about MCP is just a standard API that you can use to call a tool. And so the nice thing with MCP is that you could run an MCP server locally, or you could run an MCP server remotely as well. And so you might have an existing system that you want agents within your enterprise to be able to talk to. That existing system could stand up an MCP server in front of it so that it speaks this common API language. And then you can use an MCP client from Strands or any other SDK that supports MCP clients to call that system as a tool. And so Strands allows you to very easily both define tools as MCP servers, but also call existing tools. You can also define tools locally. So when we talk about internal tools here, these are tools that are implemented as part of the package that you're building. Very easy to add, right? So basically, like, you just take any method, you decorate it with that at tool uh, uh, decorator, and then we add it to the agent's tools, available tools. And so the comment there ends up being the tool description in this case, right? Of how the LLM can use this tool. Whereas, MCP, there's like a standard way to get the description of what the tool can do. So that's using tools within Strands. So then once you have your agent defined, it's calling tools, you have everything ready to go, you can run that Strands agent on your laptop, but you're going to want to deploy it for production at some point. And the beauty of Strands is you can really deploy it anywhere. We can deploy it on Lambda, which is what we'll show today, but you could also deploy it as a container on Amazon ECS, Amazon EKS, or Amazon Bedrock Agent Core Runtime. So lots of different places where you can deploy your agent depending on your preferences and your specific use case. So let's get into the specifics of what this would look like if we deploy it to AWS. So we've got our agent, package it up as a Lambda function, and we have it there. We got the user on one side. We could have the user directly call the Lambda function, but often we want to kind of add in some other kind of front door features. And API Gateway is a great option there. So this will enable both users and applications to access the user using HTTPS API requests. We already talked about the fact that we're going to use Bedrock as our LLM and S3 as our session store. We probably also want to provide authentication and authorization. And so we can add a Lambda authorizer and use Cognito as our identity provider. And now we can use a JWT for authorization. There's that's a pretty complete app, but there are still, other pieces around security, governance, CI/CD to kind of pull in here. And that's where like the power of AWS really comes in. And again, like at the end of the day, these agentic applications are still software applications. And so everything you know about building an applications and APIs on AWS is still applicable. So if you've built these type of applications on AWS before, you know there's a whole bunch of tools that you can use for the governance, the authorization, the security, all of those pieces. And they're all basically the same. And so now we've got our flight booking agent. So let's just walk through uh, kind of everything we've learned and like what it looks like and how it works. And so here we've got the query that comes into the travel agent. The travel agent is going to send that query as the prompt along with the tool description and the system prompt to the LLM. The LLM is going to say, hey, I want to use a specific tool. It's going to invoke the tool. That response goes back to the travel agent and then back to the LLM. We're going to store the session store so that it understands the history of what happened. And over time, this could evolve, right? Over time, we could say, oh, you know what? Like, actually, we want to like change the tools that we have. And just like other applications, it needs to evolve as like changing business needs come up. And so, building these things as microservices, start small, start smart, and scalable is really important. All right. So before we get into the lab and building things, let's just talk about a couple final thoughts, things to consider. So again, like context is everything, right? You need to understand what is in your context. It's not just the user prompt or the system prompt, it's everything that's in the context that is going to determine how well the LLM can answer the query. AI before agents, right? Like, I love agents. We're going to build some agents today, but agents are just one way to leverage Gen AI. And so you may have applications where you don't actually need agentic. You can just do, calls to Gen AI in a more deterministic way. And then remember, these are applications. Follow all the best practices around microservices. Design your agents in that way. And then verify, right? Like look and see, how these agents are working. One of the interesting things about agents, and we're not going to get super deep on this today, but some folks have been answering questions about it in the chat, is with a traditional application, when you write tests for your tests are black and white. A test either passes or it fails, and that tends to be the way tests are written, whether they're unit tests or integration tests and whatnot. With Gen AI systems, and specifically with agentic systems, because there's this non-deterministic nature, we can't always write tests that are black and white, that are pass fail. And so very often you'll hear people talk about evals, and evals is short for evaluations. And the main difference between a traditional test in an evaluation is that an evaluation can't generally be that black or white, yes or no, pass fail type of thing. It's generally you're going to grade the response, sometimes along multiple different axes from like a 1 to 10 or a 1 to 100 scale. And then you're going to determine kind of a cutoff of like, oh, if it's, below 70%, that's a failure. Or if it's below 60% across three different um behind across like three different attributes, then it fails, that type of thing. And when I say attributes, one thing that you could try to measure is accuracy of the response, but you might also want to measure the tone of the response and maybe the kind of on brandness of the response, right? Does it sound the way, you want your brand to sound when it gives that response? And so, you can measure all three of those independently, and that those would be examples of evals across, multiple attributes. So we're going to move on now to building uh, these agents, doing a lab. Um, we will kind of share out these slides later. We have a number of links for you, a whole bunch of resources. I'll leave this up for a minute just so people can grab this. But again, we'll share this again later. But yeah, lots of resources available for you. But right now, I will turn it over to Akshay, and he will get you started doing the lab.